what we're trying to do is summarize all of the transformations that we have discussed over the last several lessons. So instead of talking about the 5 individual parent functions, like the quadratic or the parabola or the V-graph or the discograph, we're just going to refer to them in general as f of x, any function. And then we're going to make a chart that helps us identify, okay, so if you have any function plus some number on the outside, what does that do? But before we start identifying in this part of the chart, I think it's really important that we come back up and really emphasize this. When we walk into our next test or anytime that we're approaching a graph of this, we really want to be thinking to ourselves, inside affects our x values opposite of the way we think. This will always apply. Similarly over here, if it's an outside transformation, it affects our y values as expected. So keeping this in mind, when we go through this chart down below, again, this f of x is just referring to any of the functions, any of the parent functions that we have discussed. If you take a function and you add c to it, that c is outside of the function. So we would say this is in our first column up here, outside y values, so it's going to move us up and down as expected. So what would I imagine a plus c is going to do? It's going to move up c units. Now, friends, if you don't like what you're like, oh, what's c? Change it. If you don't want it to be c, change this to be a 2, for example. So then what would f of x or some function plus 2 do? It would move it up 2 units. You can do this however makes sense to you. I'm just using c because that's a general term. Now, if we come back to the next one down, notice this one, this plus c is on the inside of the function because it's inside of the parentheses. So that directs me up to this one, saying inside is going to affect my x values, opposite of the way I think. So here I go, c, I'm going to go left or right. Gosh, plus c, I think I should go to my right, but it's opposite of what I think, so I'm going to go to the left. So we're going to move left c units. And again, if you want to make this a 2 or a 3 or some number that makes sense to you, please do. In the next one down, we're back to an outside transformation here. This minus c is on the outside of the function because it's out of the parentheses. So outside affects our y values as expected. Up and down, it looks like a minus c, so I'm going to go down, move down. C units. Next one down, we're back to an inside transformation because it's inside the parentheses. So again, similar to what we talked about, inside affects our x values, so we're going to go left or right, but opposite of what we think. When I see a minus c, I think I should go to my left towards the negative x values, but I'm actually going to go to the right. Okay, so then this bottom section right here, so that took care of basically the first half of our transformations. The up, down, left, right is always connected by addition or subtraction. Notice there's no more addition or subtraction in the bottom down here. We are always connected by multiplication. So times c, times 1 over c, times even this negative up front is really connected by a negative there. So let's go back up to this top one here. C f of x is really saying c times f of x. It is an outside transformation. So it's going to affect our y values exactly as expected. What do I think is happening? I think I'm going to take those y values and multiply by c, exactly like it's showing me. So I'm going to multiply y by c. And again, if you're not to c, if you don't like that, change this to a number that would make sense. Let's say it's a 2 f of x. Then you're really multiplying the y values by 2. So what does that actually mean? It's a vertical stretch of the graph. Vertical stretch by 2, by times 2. In our next one down, again, if you don't like the 1 over c, change it, friends. Maybe you want to make this a 1/3 here, just so that you've got an actual number tangible to hold on to here. What does it look like? Again, this is outside of the function, so it's going to affect our y values. So outside, y as expected. It looks like I should multiply my y values by 1/3. That's exactly as expected what we're going to do. So we are going to multiply y values by 1/3 here. And again, what does that actually mean? And I'm just using the 1/3 because I changed the c, so it's a more tangible value here. It could be 1/2, 1/4, whatever it is. What does this actually mean? If I'm multiplying my y values by a small fraction less than 1, what this actually means is that I'm vertically shrinking or vertical compression of the graph, right? So it's actually being squeezed lower, squeezed down. And then these last two, I'll put these in blue here, these were our reflections, right? So we either have the outside reflection should affect the y values, but remember it's kind of opposite of what we think here, not opposite like up above, but if you're reflecting your y values, you're actually reflecting over the x-axis. And on the inside here, inside x opposite, it's affecting our x values. So it looks like we should multiply our x values by -1. Opposite would mean I'm dividing by -1, but really the same thing happens here. So what this one truly ends up looking like when you multiply your x values by a negative is you actually reflect over the y-axis. So one of the things that becomes tricky when we put all of these transformations together, like all of the things in this table together, is which one do we do first if multiple transformations occur? So next thing I'd like you to look at is just this little note right here. We're not going to actually do this example, but when I say when we've got multiple transformations happening, we follow the order of operations. So we're really thinking here. Some PEMDAS, right? That's what we're thinking. Now, as far as PEMDAS goes, what we really care about is the multiplying, dividing, adding, and subtracting. That's really all we saw in the chart up above. So really the latter half of this. So when I look at this piece right here, I've got a ×3 out front, and then I've got this +1. These are my two transformations happening to that square root graph, right? So order of operations would tell us we're going to multiply first, then we will do the shifting left 1 unit. Okay, so let's practice a couple of these and get the subsequent domain and range. So here are two examples. Notice when I look at this very first function, I see ultimately an x cubed. It's not very clear. I see ultimately an x cubed graph, which is what I'm thinking is my disco. Right? So I'm thinking I'm going to have some sort of picture that looks like this, but there's going to be some transformations occurring to it. So let's go back to our parent graph. You could look at your notes for this, but we just plotted some points that day, 0, 0, 1, 1, over 2, up 8, -1, -1, -2, -8. So there's that original parent graph. I'm going to put that one in black, and then we'll put the transformations in color. So let's identify some of these transformations that are occurring. I see a negative out front, and again, it's outside of the actual x cubed, so that negative is like connected by multiplication. Outside y as expected. I'm going to multiply the y values by -1. What is the actual effect on the graph? It's going to reflect over, the x-axis, and we'll see that happen here. The other transformation that we see happening is this +2 on the inside. So again, inside x opposite, I'm going to add 2. Oh gosh, I think I should move to the right 2 units in the x direction, but it's opposite of what I think, so I'm actually going to go to the left 2 units. So according to both of these transformations, the one I'm showing in blue and the one I'm showing in red, we should do multiplication before we do any adding and subtracting, according to order of operations. So let's take all of our values and go back to blue. To multiply our y values by a -1, sometimes it's nice to actually look at the ordered pair there, right? This is the ordered pair on the paragraph 1, 1. If I'm multiplying my y values by a -1, that ordered pair would become 1, -1. So now instead of being right there, I'm down here. 0, 0 is kind of boring. That's anytime you multiply by 0, it's going to stay put. If you take this ordered pair of 2, 8, Again, multiplying all of our y values by -1 first, that ordered pair becomes 2, -8. So again, that point now is over to down 8. And so you can probably imagine on this side, we are reflecting down across the x-axis. On the left side of our graph, instead of going -1 down 1, the y value is going to pop up to become minus a negative or positive 1. Similarly, -2 down 8 will become -2 up 8 when we multiply those y values by -1. So this takes care of the first part of the transformation. Now I want to go to the red transformation, and I want to take these 5 points in blue and move them all left 2 units. So this guy goes left 2 units. This guy goes left 2 units, left 2 units, left 2 units, and left 2 units. And here we still have the disco graph, the x cubed graph, but this is what it would end up looking like in red here. This is the final product. When you are graphing this on paper, I actually want to see your process. I want to see the 3 different versions of the graph, but you could just darken in the final product so I can tell in your pencil which one is the actual final. And I definitely want to see the key points here for each part of the graph. So then if I take that pencil out and I find the domain, we would say, oh, we're going as far left to as far right as possible. So we'd say -infinity to infinity. And then similarly for the range, we go as far as low as -infinity all the way up to positive infinity. Okay, let's move on to the next one. So here again, I'm seeing in my brain, I see these straight line graphs, so I'm thinking absolute value graph, which is the V graph, right? This is what I'm thinking in my brain. So then I go back to that parent function and I say, all right, 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. These are those ordered pairs on our parent graph. What's going to happen to these 5 points that we have highlighted here on the graph? Because these are the original points. So let's talk about one of the transformations that we see here. Well, I've got this -2. It is outside, right? It's outside of the absolute value. It's not on the inside of the absolute value. So it's outside. So this -2 is going to affect our y values exactly as expected. So we're going to multiply y by -2. So there's actually 2 transformations that we're achieving by doing this. We're actually reflecting over that x-axis, and at the same time, we are stretching the graph vertically by a factor of 2. But we can do both of those things at the same time. Similarly, over here, if I grab a different color, maybe I'll grab this guy right here. This +3 over here, that is outside of the absolute value, outside y as expected. So it looks like I'm going to add 3 to the y values. I'm really going to do going up 3, right? So it affects the y value, so it's an up or down. +3 means we go up 3, exactly as we'd expect. And again, thinking about order of operations, we're going to do the multiplying first. So let's go back to green. Take all of this ordered pair. So here's the ordered pair, 1, 1. We're going to multiply the y by -2. So that ordered pair would become 1, -2. So now, instead of being right here, we're going to go over 1 down 2. The 0, 0, again, is kind of boring because every time we multiply by 0, it's just going to stay 0. But if we take the next ordered pair, 2, 2, that original point, and we multiply the y value by -2, that becomes the ordered pair, so the x value stays, y value becomes -4. So over 2 down 4. By symmetry, I hope you can see that on the left side of this graph, this would be -1, -2, and -2, -4. So it is both an upside down V, so there's that reflection that we talked about up above, right up here, right? There's that reflection, and it's been stretched vertically. So it's like somebody pulled the ends of the graph and pulled it apart. But again, this is not the final product. We now want to take all 5 of these points in green. Oh, I'm not sure what just happened here. We want to take all 5 of these points in green, and we want to move them up. I kind of lost part of my graph here, I'm sorry. And we want to move them up 3 points. So let's go back to our orange color now, taking care of our last transformation. This guy goes up 3. 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 And this guy goes up 3. And so the final product is the orange graph. Again, you could just show me this on your paper by darkening in the final product. So this is the final here. And if I get out that pencil and I ask myself, how far left to how far right does this go? I'd say negative infinity to infinity, because I got arrows on both ends over here and over here. But for the range, the low value is negative infinity, all the way up to, we max out right here, it looks like at positive 3, and we actually hit that value, so we'll put a bracket. Okay, bottom part of this lesson here. What if we don't have one of our parent functions? What if I make up a function like these 3 points and I say, hey, this function, we'll call it f of x. We can still do transformations when it's not a specific, the v graph or the parabola or the square root graph. We can still do transformations. We would identify the inside as being on the inside of a parenthesis, and this guy would be outside of the parentheses, so this would be an outside transformation. So again, what we would do, similar to how we approached the above 2 problems, is I would start with my original graph. So my original graph has an ordered pair 1, 2. It also has the point 3, 2. It also has the point negative 2, negative 2. So this is what we're calling a new parent graph right here. What's going to happen to these 3 points? Well, let's identify some transformations here. So it looks like I've got this guy right here, again, is on the inside. So inside x opposite, it looks like I should head inside as my x values, so left and right. It looks like I should head towards the positives because it's plus, but we're going to do the opposite and go left 1. And then we also have this minus 3. It is outside of the parentheses, so outside affects our y value, so up and down. As we'd expect, that's going to take us down 3 because it's a minus 3. Now, the good news here is they are both adding and subtracting. There's no multiplying, so we can actually do them at the same time. So I'm going to do that one. Maybe we'll just go with that purple. All 3 of these ordered pairs are going to go left 1 and down 3. So taking this guy right here, we're going to go left 1, down 1, 2, 3. So that one has moved left 1, down 3. This guy is now going to move left 1, down 1, 2, 3. This guy is going to go left 1, down 1, 2, 3. And so this whole thing is still the same graph. It's just been shifted. And if we look at the domain and range, the leftmost part of this, there is no arrow on the end, so it goes as far left as negative 3 and as far right as positive 2, but we are actually hitting those points with solid points, so we would just put brackets around. As far as the range goes for low to high, the low point of this graph is at negative 5. The high point of this graph is up here at negative 1. And again, we hit both points because they're solid circles, and we use brackets. Moving on to our last one, let's again start with what we're calling this new parent function, which is really just these 3 ordered pairs putting together here. So I'm going to put those up on the graph to start with, negative 2, over 1 up 2, and over 3 up 2. So these are the original points. Let's identify the transformations that are happening to this graph. So the first thing that I might notice is I've got this 1/2 out front. And if I look at how that 1/2 is connected, it's butted up to it, so we're going to say it's connected by multiplication. That 1/2 is also outside of the function. So looks like outside y values as expected, looks like I should multiply my y values by 1/2. It's exactly what we're going to do. So multiply y by 1/2 is really what this is saying. What does that mean? It's a vertical compression at the end, right? If we're getting smaller in the y values, it's going to shrink us vertically. Another transformation that we notice here is this negative, and notice it's on the inside. So that's inside x, and we're going to multiply x values or divide them, because opposite technically means we should divide, right? Opposite of what we think, but dividing by a -1 is the same as multiplying by -1, just changes the sign. So multiply x values by -1, which again is that reflection. We should see a reflection over the y-axis. So if we take these ordered pairs, sometimes it's nicer to actually see to do this multiplication by looking at the ordered pair. So let's take, for example, this ordered pair of over 1 up 2. Because I'm multiplying in both cases, up here and down here, red and blue are both multiplication, and they affect the different variables. We could do them at the same time. Let's multiply our x value by a -1. Let's multiply our y value by a 1/2. So this ordered pair would become, well, 1 times -1 would be -1. 2 times 1/2 is 1. So this ordered pair would become, this guy right here, is now going to become -1 up 1. Let's do the next original point here. So over 3 up 2, we're going to multiply our x value by -1, our y value by 1/2. So this would become -3. Again, half of 2 is 1. So that ordered pair, so again, the original point there is now going to become -3 of 1. And then finally, to do this to our very last point here, we've got the ordered pair -2, -2. And so we'll multiply the x value by -1, multiply the y value by 1/2, and that whole thing would become then -2 times -1 would become a +2. Half of -2 would become a -1. So that ordered pair would become 2, -1. And we end up connecting here. So we can actually see that reflection over the y-axis. We can also see that we have been compressed vertically. To do a quick domain and range on this blue graph, that's our final right there. To do a quick domain and range, we'd say how far left to how far right. -3 is the leftmost point to +2. And again, there's solid circles, so we'll put brackets around it. To do our range, the low point of the graph is this -1 all the way up to 1. And again, brackets here.
Elliot McKnight